Hello everyone. In the morning session we heard a lot about automated translation and we heard different views or perspectives. We had those who spoke in favor, against automated translation, but the question that we all care about is why automated translation is as it is, and can we do something about the quality of those translations or improve the quality? Let me go back in time and sort of go to the roots, as the speakers in the morning session did. Translation, the role of translation is growing in multilingual Europe. We have 24 official languages, and in CF context we also have to add 2 languages on top of those 24. And, you know, from legal perspective, we need to provide the translation across all those languages, so there are around 500 language pairs, and documents have to be translated in all those language pairs, which is, of course, impossible for a human being to do, even with all the aides and those who are translating, interpreting on a daily basis know that the best friend of a translator interpreter is translation memory, basically a translation memory that compiles parallel texts or text pairs, and you don't need to translate it again when you encounter a similar type of translation. But translation memories contain various units, and those units may be also updated if they are slightly different from the sort of original translation. But that's not a magic wand, that's not a silver bullet, because you usually encounter new text with new untranslated sentences or segments, and machine translation can of course help solve this problem. But let us now talk about the role of machine translation and the quality of machine translation of documents or text translated through by machine translation tools. Now, as regards to quality, all of us, have, once or twice considered why the quality of the machine translated texts are bad. So we speak our native languages or a foreign language that we've mastered sufficiently. So for us, it's not a problem to create or translate their sentences, whereas computers are struggling with translating new sentences. One of the problems is polysemy. For example, many of us can recognize the meaning of a word in a context or in a sentence, and we can easily sort of crack the idea or thought behind the sentence, but the computers can't do that. For example, raining cats and dogs, if we don't know what it means, then if we translate it in Latvia, then it would mean that there are cats and dogs, falling from the skies during the rain. But actually it means heavy rain or showers, and we have a saying in Latvia that it's raining like on a midsummer solstice or midsummer day, or basically raining heavily. So polysemy is the main problem, and we tend to express the same notions or describe the same notions differently across languages. And this is the knowledge that we as human beings accrue over our lifetime, but a knowledge that a computer never will be able to access. But there are things that computers can do. They can choose the right words, the right endings, and they can structure the sentences in a human-like manner. So that's what it's all about. This is something that we need to focus on. We need to broaden sort of the knowledge base of the machine translation tools, and that's where you come in. You are sort of providing those resources. Usually when I give lectures to my students, I ask them, when did the machine translation idea come about? Actually, the idea of the machine translation tool was conceived even before the first computing device in early 1930s. And then, with the development of the computing systems, with computer devices, the machine translation idea developed further in the 1950s. So basically, machine translation dates back some 60 years into the previous centuries. So the polysemy, word, order, sentence structure are the problems or issues or challenges that have been tackled by the machine translation experts. So if you go back in history, the first machine translation tools were the so-called rule-based systems, Macleish triangle, it originated in 1954 with the development of computing devices, with computing sciences, when the Georgetown experiment was conducted and texts were translated from English into Russian. So basically, simple words in one language were substituted with same simple words in another language. That was the sort of literal or direct translation as we know it. And you might ask, what about the polysemy words or polysemantic words? And systems are unable to translate those polysemantic words. With time, people grew smarter, and they incorporated new knowledge into those translation systems. Morphology, syntax, and semantics became a part of those machine translation systems, and the so-called transfer systems were created, again, based on rules, transforming or transferring the sentences from one language to another. And Sila, in her presentation, mentioned already that the first systems were introduced by the European Commission in the 1970s and the 70s, and those were rule-based systems. The problem with rule-based systems is, inability to service 500 language pairs. It's difficult to sort of repeat this triangle in the case of 500 language pairs. That's why what concerns modern machine translation systems or tools, modern machine translation systems are using the machine sort of or automated learning or like a child, a child is born not knowing any language, and they are listening to the people around them, and with time they learn particular words and what they describes. And what concerns a child, they learn the right sort of pronunciation of the word and the right form of the word, although they know nothing about the morphology or the syntax. But, based on what they've heard from their parents, they automatically learn how to, or they master the particular language or the native language or mother tongue. So going back to history or historical overview, the idea of using a data to teach the computer how to translate properly is nothing new. This idea 60 years ago was presented or introduced by Warren Weaver, who said that if I see a text in an unknown language, I see it as encrypted paragraph. The only thing I need to know, or the only thing I need to do is to crack the code, and then I'll be able to translate it. And that's what machine translation today is all about. And let me elaborate on that now. So the main sort of purpose of what I just told you was to understand how machine translation works and how you can contribute by providing the resources to the Latvian, say, Hugo or other machine translation tools to make them better. This is the sort of the most technical slide in my presentation. Let me explain to you how machine translation works. Machine translation works with parallel texts in, say, two languages or a text pair in English and Latvian. It creates a sort of a bilingual pair, with corresponding texts and segments in both languages. And then you need a corpora in another language, say Latvian in our case, and from that you create a language model. Or, going back to the comparison with a child, child learns the proper pronunciation or form of words or sentence structure from what they hear. So basically they learn much like computers learn, and they integrate then the knowledge from the corpora, from this dictionary, with the language pairs or those parallel texts, and then selects the most appropriate or most precise translation that is stored in the translation memory or can be retrieved from the translation memory. But as I said, this was the most technical slide in my presentation. So what sort of data machine translation program software needs? So first of all, human translation. And here's an example of one of the European Union regulations. So basically, sentence in English and the corresponding translation in Latvian, English sentence, Latvian sentence, and and a part of this sentence in another language. So basically, parallel text is what it deals with. So on one hand, the more data, the better. On the other hand, the data must be precise as well. And now let me focus on the precision of data or the quality of data. Basically, by this, I will answer your question, why does MT produce good translations at times and bad translations at other times? So what can a computer learn from data? Well, basically, it can learn three types of things. Make three kinds of conclusions. The relations or links between sentences. Take the block and, what is the corresponding translation, say, in Latvian? Or take the green block, and so basically it computes or processes the data and learns how those translations are produced. And then it also learns how to translate the phrases. For example, block is translated as a block, a square, a wooden square, and that sort of the thing. Green as the, type of color. And then it also learns how to translate the sentences. Take the green block. Take the block green is an acceptable translation. The word order in this case is a bit off, and we would be, quite surprised to see that in an official document. Seems pretty much straightforward, but what concerns sentence production, it would be nice, for one sentence in English to have a corresponding sentence in Latvian. But sometimes sentences are being split, say one sentence in English may be split into two sentences in Latvian, or maybe even be split in 2 or 3 sentences, or vice versa. Translation may be integrated into one sentence where the source might be, several sentences. So all of that is processed by a machine translation software or tool. And let me give you a very, sort of traditional example that is mentioned all over in different conferences. So this is Chinese, English menus. Those of you who are not good in Chinese don't understand those Chinese signs. Basically, from this symbols, you have to guess the meaning. That's the same as the machine translation tool does. Usually my students already see that this column is almost the same, or the line is almost the same, so most probably one of those symbols is soup. But let us have a look at a more difficult case. And there's an egg drop in 3 lines here, and we can try to guess which sort of Chinese sign corresponds to this English translation or English phrase egg drop. And the first thing that we may notice or conclude, the first thing that we can see is a sort of having one hieroglyph only once, so that most probably can be eliminated as not the one that signifies the egg drop. And then, the same as in the soup, we can see that in all 3 cases, but we can also see that it's on all lines, so that means that it's a soup, so most probably it will not be an egg drop. So what are we left with? Well, we have this symbol after singling out the others, or eliminating the others, so most probably this is the right sign for the egg drop, the phrase egg drop, or the word combination egg drop. And the same can be said about the wonton. We can see that there's the reoccurring sign on all these lines, and thus we can single out or eliminate all the others that are most probably wrong. And that's how the system works as well, similar to our brain, basically. So this little dictionary knows a lot about the Chinese soups, and I do assume that, the translator will not have any problems translating that after learning the way that I did show you just now, but they don't know something that is not, seen there, something that is not reflected in those symbols and signs. And much like children, people, learning language have the inherent knowledge and the knowledge that is being acquired. So the question is whether from the word level text, you can learn how to translate. Yes, easily, if we are talking about very simple and straightforward sentences and words. And let us continue with the same example of red and green blocks. And this is a very straightforward, very primitive, very easy to comprehend example, just to show you how a computer sort of learns how to translate. Take the block. Take the square, take the green block, take the green squares, the translation, or whatever. Well, we see that, take means paņem in Latvian, red is being translated into color, and that the article is not being translated. So basically you get the statistics. On the frequency of usage, take has been used 2 or 3 times in this case. What concerns a block, it's a much interested case. There are different endings in the case of Latvians, depending on the translation. And so there are different endings depending on the case. So there is a put the red block sentence that needs to be translated into Latvian. What does a computer do? It basically checks the frequency of use, and it concludes that put means put it somewhere down or place it somewhere. So red is translated as red, and there's also the difference in the case ending. So it uses or chooses the one that is most frequently used, and klaucītis with a different ending is used in this frequency. And basically that's the way the logic of a computer, it basically chooses the most frequently used one, and that's the translation model, the statistical translation model based on the frequency statistics or the frequency of use of a particular word as in translations. Now if we consider all the alternatives, there are 4 of them, put down the red block, the red block needs to be put down. Well, this is the case ending, very typical for Latvian, very difficult to translate into English because there's not the same sort of case transition as in English. So you can rely on your natural sense of language to see the Latvian translations. So what can we do with those inappropriate translations in this case? There's another resource available to us, the monolingual resource, or, well, the Latvian corpora. So this language model, what does it do? Well, it basically chooses the most appropriate translation of all the available translation. As you saw, there are 4 sort of alternative translations. We asked the language model which are the best and which are the worst alternatives. It suggests that the red block is an appropriate or acceptable. Red blocks won't be appropriate. Of a red block will not be acceptable, and another variation with the case ending would be appropriate. So if the red block is used much more frequently than the other alternatives, then we get the right translation. If we're unlucky, if it chooses as the most frequent or suggested translation the wrong translation, then most probably we'll have problems from the Latvian language point of view.
Thus, the machine translator uses 2 types of models, this translation model and the linguistic model, which describes the structure of good or acceptable sentences in the target language. So as you see, this turns into what I described previously. We apply all the applicable possibilities and choose the best suited one. You see, you can hit or miss with this red block. Therefore, researchers have taken a step farther, and they no longer use this word-for-word translation because they don't know, this doesn't apply a context, but instead they use the context translation. This is the new approach, and that is how you try to avoid the use of the linguistic model, which is not acceptable in the target language. And therefore, the translations are shaped out of a phrase, or say you use put the red square or on the red square and so on. If we were to return back to the previous example, so what changes? I took the liberty of adding a couple of more sentences so that we start generating statistics. So we have put the red square on the green block. And if we translate word for word, then we get incorrect case endings, and nobody will be happy with this kind of a translation. And there it would turn into put the red square on the green block. If we chop it off into smaller blocks, then we acquire a comparatively bad translation. If instead of words we apply phrases in our languages, in the dictionary, then we and use it in the sense that we have the red square or on the green block and so on and so forth, then, applying this method, we analyze the most frequently used phrases, and we have the put, which we translate knowledge into put, and then we translate the red square. That means sarkano kvadratu is the red square, and then we have uz zaļā klucīša on the green block. So we acquire a much more accurate or maybe even perfect translation, which might not be the case for all of the situations in life. So what can we conclude from this? Currently, the phrase-based statistical translation is used most frequently. It doesn't go word for word. It instead translates phrases, and it applies statistics. And if the correct phrase is used more frequently, then the translation will be correct. And vice versa. If a different case ending is used more frequently, then the translation will be less accurate. Such large companies as Google and Microsoft apply these technologies, and Tilde in Latvia, and as far as I understand, Hugo.lv also uses the phrase-based machine translation, and this technology uses the Moses open source PBSMT. And the new solution that is being introduced in the European Union also applies the Moses open source tool set. The key task of my presentation was to explain why do we need data. So if we have data, and if the data is correct, then we can hope for a good and high quality translation. If we lack data, or if we lack data in the area that we wish to translate, then the translation is as it is. And it is clear that we need parallel corpora, we need text in the source languages, and if we want to adapt our machine translation system to a particular area, then we definitely need dictionaries, terminology, ontologies, classificators, and the named entities, such as names of organizations, names of countries, and all of the other things that we can name and that are language-specific data. And the question is how much of such kind of data you need. On the horizontal axis, we see millions of words that are necessary for establishing a good or developing a good language tool. And then we can apply the this blue score, sorry, and then it should be at least 50. In order for us to acquire a good system for a domain-specific translation system, then we need approximately 80,000 words. That means quite a lot of data. Another aspect that I would like to emphasize at the end of my presentation is the adaptability to a specific domain. An example, if we have adapted this, say, so to speak, tool to Harry Potter, and now if we want to apply it for some kind of financial text, then nothing good will turn out because it lacks the knowledge in this specific target domain. Therefore, my encouragement that will most probably be discussed in greater detail further on would be to think about the language data that is managed by public authorities. That might serve as the basis for improving this machine translation tool or tools. And I would like to say that if we wish to obtain a high-quality machine translator, then we have to adapt these tools to specific domains. And definitely, we will all benefit from that because we will all be able to make use of high-quality translators, and we will be able to connect them with other EU language resources. Thank you.